So, about me, I'm Jakub. I'm coming from Prague. And yesterday, I saw all the awesome stuff that people do with Pester, and I was amazed. Because people are using it for awesome stuff, and it's really cool. And they build stuff that I couldn't even imagine they could build, and they are doing it really, really nice way. Me, myself, I'm focusing more on the internals of Pester, on developing the framework itself, because I am a developer, I do a .NET development by day. And so for me, I don't do that much PowerShell or environment validation and so on. So maybe I can offer you some perspective from, guy who does unit testing every day, almost all day, but not a perspective from a guy who has this huge environment full of servers who can test it in one runtime. But that's why I'm here to talk with you about the internals. So this is me on the internet. Maybe you see my avatar sometimes if you did anything with Pester. You can follow me on Twitter if you want. If you have any questions or if you need some assistance with testing, either go to Slack, powershell.slack.com. We have a testing channel there, and I'm there quite often. Or send me an email or tweet to me on Twitter. I will try to help you. Come on. Maybe not. So my agenda is quite simple. I want to tell you how Pester works internally. So when you look at the actual code, and there is a lot of tricks that we need to do in order to keep the code safe and you to be able to mock as much stuff as you can, then you won't be very confused about what's happening. So I want to show you the basic concepts, and I've put them in slides so they are disparate. So you get an overview and you can really understand what's happening. And hopefully we will get, this doesn't work, we will get more contributors for the project, because at the moment it's me, it's Wojciech, it's few other people, occasionally someone sends a PR, but it would be great if we had a community around the framework itself, if we use it for awesome stuff like OVF or DBHX. So if you want to contribute, maybe you can do some conceptual work, like we want to mock classes. How do we do it? We want to relax mock type so we can use it for AD better. So how could we do that? Timeouts for its, that's something that people ask about quite a lot. Or maybe you can just come and you can read the documentation and write something new, or just tell me, well, this cannot be understood. Could you please improve it? And I will try to do it, hopefully, if I have the time. Or maybe someone else will try to do it if we build a community. So huge group of users of Pester, so we won't just make the framework better. If you're just looking for a place to start, we have few issues that are marked as good first issue, so maybe you can pick that up. So for those people who are not familiar with Pester, this is how a typical test looks like. So here on top, we have the production function that we want to test. At the moment, the function doesn't do anything. It just returns an empty array. And then we have another file that is called getplanet.tests.ps1. The .tests is important for Pester. And on the top of that file, we are .sourcing the getplanet ps1 where we have the production function. So we can execute it in the current scope. And then we have three keywords: describe, it, and should. The describe is a container for another describes or for it blocks. The it block itself is the test. That's where you put your code, and that what ends up either red or green, depending on the outcome of the test. And then we have the should keyword, which is an assertion that determines if your test will fail or not. Well, that's not entirely true, but we will get to the details of that in a second. So, a bit of warning, the code that I will be showing you is simplified PowerShell code. It's still relevant, it's still what you will see in the framework, but there are multiple concepts mixed in the same places, and I just want to show it one concept at a time. So maybe I'm omitting parameters, maybe I'm shortening the SMA namespaces, There are questionable line breaks and so on, everything for the purpose of fitting on the slide and making it readable. Sometimes I'm using like a meta code where I'm actually putting the result of what I would generate with some more advanced code inside of the slide. But I will point that out, don't worry. So in general, a test framework has only a few pieces that are important. It has a test discoverer, a test runner. The test discoverer finds your tests, and the test runner will run it. Easy as that. So if, for example, in XUnit and C#, you define a class, you define a method on it, you put an attribute on it, that's theory or fact, or with MS Test, you say test method. And the test discoverer, we go through all the classes that are public that you have. It will find those that have methods with that attribute, and it will collect them. And then it gives it to the test runner that will somehow execute them by instantiating the class running the method. Very easy. Then we have an assertion library in most of the testing frameworks. In many of the testing frameworks, the assertion library is purposefully kept simple, so you can have different libraries that only specialize in creating assertions and providing assertions. In C#, that would be XUnit, really simple assertion library. Then you have Fluent assertions, which are great influence to the features I'm implementing currently in should, that has object equivalence and the because stuff and so on. So they are disparate. But in PowerShell, the testing wasn't always a thing. We are still learning about it, still finding use cases for it. So we are trying to include as much in Pester as we can and has the assertions as powerful as we can. And then we have a mocking library. This is also usually separate because usually you have a strong type system, you have to have abstractions over your objects, and so on. In Pester, we have to do it in a way that we connect it to the framework because of some limitations that I will talk about. And then, of course, we have output to screen and output to some kind of format. Usually it's NUnit XML, but sometimes it can be TRX, and there is actually, I think, a pull request for TRX in Pester as well, so you can easily integrate it with Visual Studio Team Services. So now we will go to the concrete stuff in Pester. And you will probably see that I'm omitting quite a lot of code in those first slides. That's because there are concepts that I haven't covered yet, and so I don't want to pollute it with, and also the code is really simple, and as we will progress, you will start figuring out what exactly would go into those places where now there are just comments. So it's boring and simple stuff. So test discovery in Pester is connected together, unlike in most frameworks. And the problem here is that the Pester tests are just scripts. And that has an advantage, which means that you can organize them however you want. The structure is very loose. You can wrap them up in for eaches, you can generate the test cases, and so on. On the other hand, we cannot just analyze your test base and tell you, those are the tests that you have. Do you want to run them? No, we have to run all the code and run the tests at the same time. So we cannot just run a single test. And that's some feature that's asked about a lot, like put tags on it. I would love to do it, but it's mostly about how you write your tests than what I do in the framework. If you include any code outside of the blocks that Pester controls, we cannot just execute everything, because then we might be doing some destructive changes or leaving some junk behind, and I don't want to do that. So in reality, it's this simple. We are just using getChild item to get all the tests.ps1 files recursively in the current folder structure. You might be wondering why I'm not using the dash directory parameter here, but we are still PowerShell 2 compatible, so we have to do stuff like this, like the $PSS container, which is really, really old school. And then in a for each, we go through each of the test scripts and we execute it. And then we catch any errors that happen. And finally, we just throw away the state, we delete test drive, and that's it. The code that would go in those blocks is extremely simple. Just write there to the screen, delete this, throw away this. You might wonder, what is this weird loop doing here? That's just iterating once, right? Because the do loop just goes till until is true. So we have this extra loop. So this is here because you can put break keyword in your script. And if you do that, you will, instead of going here and going to the reports and going through all the stuff that happens inside of this place, you just jump out of the test run and you don't even progress to the next test script. So we want to prevent you from doing that. And you will see this weird loop in more other places, so don't worry about it. Useful trick though, if you want to do things like this. Then we have describe and context. So those are very similar to what you've just seen. We have try catches, we are executing a script block that you pass to us. But on the top, what we are doing is that we are setting up the Pester state. The Pester state is like an internal object that just holds the results of the test cases, some other things, some locations, and so on. Nothing very complicated. In which block we are, so we can protect you from putting mocks outside of describes, but maybe protect is not the right word. We have to use mocks inside of describes, otherwise we cannot count them. So that's why it's there. And so we are checking if the Pester state is null, and that's because if you use invoke Pester, the commandlet or the function, we will set up the Pester state at the start. But if you don't, and you just want to go into your editor, press F5 and run the script and get the output, then we have to do it somewhere, and so we do it in describe. And I find this feature very useful because I want to just interactively run my scripts by F5. It's very convenient, and I really like it. I don't know about you. Anyone who likes this feature? Oh, that wasn't very responsive. Should we try it again? No. So wake up, it will be lunch soon. Now we have it blocks, and the it block itself, very similar to what you just saw. Try, catch, do, execute a script block, put some params in, not very interesting. What's interesting about this one is that we catch an exception and we save it in here in the error record, which is the result of your test. And if there is an error, then we know that something bad happened in your tests, and we should write a red result instead of a green result. So that's how it works. That's the thing. And the cool thing here is that there used to be a progress report called there, but it's not anymore. Because on Linux and Mac OS, this was extremely slow. When I removed it and I sent it to the build server, it sent me an email back in 2 minutes. And I was like, okay, what did I break? It was, I don't know, 10 p.m., and I really wanted to go to sleep. Or maybe it was midnight, I don't know. I go to sleep early. And it really shortened the time from 30 minutes of run to 2 minutes just by not using report progress. So there goes that. I don't think everybody was ever using it anyway, or just blinking. Wasn't it? Did you find report progress useful? I never did. Then assertions. Assertions really important for Pester tests because they let your test to fail. So we need to cover 2 topics. How do they work in Pester and in general, and how the syntax in Pester works. So first, how do they work? How are we doing on time? Pretty good, I guess. So this is a model of an assertion. You can see it's an if that throws an exception. And that's it. That really is what an assertion is. And a lot of people think that there is some secret language of assertions where the should connects to the framework and tells it, hey, this test failed. And that's not true. We are just throwing exceptions. And if you throw an exception, then you can write your own assertions. So this is a useful assertion that doesn't have any fluff. You can understand exactly what's happening. If you know how the EQ operator works, then you can understand all the test cases or the use cases around it. And it's not as complicated as Pester B. Maybe if we switch to the real code, if we're able to do that. I know, I will move it there. I'm just looking for the correct file. But thank you, whoever that was. So this is how it looks like inside, and it's terrible. Oh, we can still go on. So this is not something that you want to reason about when your assertion fails, right? So why not replace it with something simpler, if you can? We have to do it this way because there is a lot of junk that comes, and we have backwards compatibility and so on. But you don't have to. You don't have to put up with it if you don't want to. Just throw an exception from an if, and you are done. Next slide. So then there's another category of assertions, and that's an assertion that expects an exception. That's very similar, but we just need to revert it back. So if there is no exception, we want to fail. And this is almost how we do it. This is how I do it in my assert module. So you do try catch, you execute the script block that you give to the should throw, right? You know that you have to put your code in a script block when you're passing it to should throw. And then if there is no exception, which will go here, then it will just throw. And if there is an exception, then we will save the true. And then we will also return the error object back to the caller. In Pester, you can now do this by passing the pass-through parameter to should throw. You might find it quite useful if you have a complicated exception and you want to inspect it afterwards in some other assertion, like assert that inner exception of inner exception of inner exception has this value. So we cannot reasonably give you a syntax for that, but you can easily do it by dot notation and a second assertion. And we also throw away the output of this script block execution, because if that succeeds, we don't care about the output. We want an exception. So we are interested in the exception and nothing else. So, as I said, Pester B, not a good place to start investigating how Pester assertions work. Much better place is Pester contain, which looks like this. You have an actual value, you have an expected value, then you have a switch to negate it. So you can say pest should not contain. That's why the negate switch is there. And then you simply use this contains operator that's present in Pester, in PowerShell, sorry. So you can check if the item is part of the array. If you want to negate it, you simply just negate it as a Boolean. And then instead of throwing an exception, what we do is that we create a result object and then we throw the exception in the should. I don't think there is a strong reason to do this. We could easily throw the exception directly in the assertion, but that's how the framework is structured at the moment, so that's why I'm showing it to you. So assuming we have this Pester contain function, we need to register it somehow with should, right? Because we have this should dash contain to call it. And so on importing the module, every PS1 file is .sourced to inside of the module, and among those, the contain PS1 is as well. And we have this function that will do add assertion operator. So we give it a name, we give it the script block, the body of the function to use, and then we give it a few more parameters, maybe like supports array input, so we can collect the input from the pipeline easily. And then we call this method that will just add it to a script scoped table inside of the module under the name that we specify. Okay, makes sense to everyone? Yeah, I see you nodding. It's not very difficult. So when we want to execute an assertion, we need to first get it from the table, and we easily do that just by, looking in the table. And how we get the name, we will figure out in a second. But then we simply take this entry. I'm not sure if I called it correctly on both of those. Oh, sorry, I called it script block in here. But it should be test instead. So that's what we are executing, the script block that we passed in, that was the body of the contain function. Then we split parameters over it, and then if the result did not succeed, we simply throw a new exception in one place instead of throwing the exception in multiple different places. Okay, can you see the same shape as what we had before in the model? But we're just wrapping it into the should keyword and then executing a script block from some function instead of doing it all in one place. I hope you do. And then we have two different syntaxes for should be. So the legacy syntax is the one where you could say should be 9 without any dashes, or should not be 9 without any dashes. This was just based on positional parameters. So we then parsed each of those parameters and checked, is this not okay? Then is it some valid assertion? If it's not, throw an exception. If it is a valid assertion, then execute it. If it was not, then try to find the assertion on the next place. And this can work if you only have one thing and one not. But if you want to do something like should throw fully qualified exception ID, has type, and so on, it doesn't work. So we had to move to the modern syntax with the parameter sets, where we can say should be, and that would be actual value, should be actual value 9, or should throw fully qualified ID and type, and whatever else maybe someone adds. So we can do that, or pass through. So we need multiple sets, so we have more expressive syntax. And actually, with every major release of Pester, the syntax has changed. So I don't know what we can do now in Pester 5, if there will be things like that. But maybe we could just make each of the assertions one function that would be separate. Or maybe not, maybe we can just keep it compatible for one time. So where does the B come from? Because here you had to figure out the name for the assertion operator, and there were no parameters, and now suddenly we have should that also has no parameters, and we can specify B to it. So this is just dynamic parameter set. What is happening here is that when we call the add assertion operator, inside of it, it will call this function, add assertion dynamic parameter set. And the code here, that's one of the pseudo codes that I wrote. There's actually like whole, reflection-like code that generates the item and says, create a new parameter object that has parameter set name B and so on. And it's difficult to understand just if you put it on a slide, but it's easy to understand if you read it on in the code. So I just put the result in here so you can easily see what's happening. So a param block in objects like this is defined. We have parameter set name set to B, and the B is mandatory, so you have to specify it in order to select the correct parameter set. And then, of course, each of those parameters would have this parameter set, so they belong to the same parameter set, and you can have different values or different parameters for different parameter sets. So for the B, it would be an actual value, an expected value, and not, and because. For should throw, there would be the fully qualified error ID and a message and so on. And then we just add it to a script table in here, or script scope table of the parameters. And then the actual should just defines a dynamic param block where the parameters are looked up, they're attached to the command, And then in the IntelliSense, you will just get should-b, and you can write it out. So it's not very complicated, but the code that is very verbose, so I didn't want to show it entirely. Okay, makes sense? That's great. So now we can move on to mocking. And that's one of the most advanced and most complicated features that we have in Pester. And that's why I'm very thrilled to show it to you and how it works. So someone not familiar with mocking? Okay, the concept or how it works, hopefully it's just the concept. So a mocking we use, so in this case we have this getPlanet function that internally would call getContent, so it can load the planets from a JSON file. That's what our function would do. And so we don't want to fiddle with files. We believe that getContent works correctly. We believe that convert to JSON works correctly. We just want to say, if there is a planets JSON file in the current folder, then just load it. And if it fails, it fails. We don't really care. We just want to validate the call to the getContent is there. So we create a mock, so we don't have to create the file, load it, put the right content in it, and so on. And sorry. Then we call getPlanet. And then in the end, we just look at the mock table and we just say, if getContent was called at least once, and it was called with this path, with a path that contains planets JSON at the end, then we consider it success and our test can pass. If it wasn't, then we will fail. So a poor man's mock would look like this. We would use function shadowing to define a function closer to the caller, and assuming that getPlanet is not from a module, we would get the same functionality. So we would provide a path, we would filter on the path, and if it was formatted correctly, had the correct value, then we would set the script get commands to 1. And then in the end, we would just do should be on this global state or on this script scope state. And that would work. But it's a lot of work. You have to know what the parameters are. You have to know where exactly the function is located. You have to switch to module state and so on. So it's not very convenient. So we can shadow functions, we learned that, but in PowerShell there is sadly no set functionality that would enable you to put it in a parent scope and generate the body of the function at the same time. So what we want to do is that we take the function, we give it a name, we generate the body so we can call to the whole things that count the mocks, do call through, filter parameters, and so on. All of the details I will show you in a minute. And then we want to generate this function and set it right next to where the mock was called. So we would do the same thing as the function keyword, but with our own function. So technically, it's possible. You can do it, because invoke expression does that. So you can look at the implementation, take the internal details, invoke the same internal API, but you have to do it in C#, because otherwise you don't get the reference to this one object that you need. And then you can do it, but it's a hack. So if anybody knows about a public API that's compatible with PowerShell version 2 that can help us remove reflection from our code, I would be more than happy to hear about it. And so since we cannot just change the parent scope of the function and define a new function in that so it gets closer to the caller, we have to define it globally. Then we have to take note that we run out of the correct scope and remove it. And that's another problem, because you cannot just remove the function without removing the previous function, I think, or at least what I know of, through the PS item drive. So if you do that, you will remove the original and also your mock. So you don't want to do that as well. So luckily, there are aliases, and we can use aliases because if you create an alias and you point it to a function that has the same name, it won't work. And that's great. because then you cannot have an alias that has the same name and calls the same function. If that was possible, we couldn't do what we're doing, but we can because it's not possible. So we can take an alias or a function, resolve it to the original command, and that way we know that there won't be an alias that has that name, and if there is, then it won't work and won't do anything useful. So we leverage that. Luckily also, aliases are the first one to be picked up if you're resolving a function. So if we have an alias that's called getCommand or getContent or getDate, and we assign it to a function that has our behavior, then it will be picked up if someone else calls. And if we create an alias that will be module scope, so it will have the long name, then it will be picked up as well. And that's exactly what we're doing. So here's another model before we get to the real deal. So we have this script, mocked history, and we have this function with a random name. Random because it will be global, at least in the session state, so we cannot rely on not running in conflicts with it if we set name like, I don't know, Pester underscore or something. So we just opt out, we opt for having it random, and in reality it's a GUID. Then we set an alias for getContent and point it to the to the bootstrap function, to the function with the random name. And we also create another alias that will have the fully qualified name and so on. So whatever you throw at it, it will resolve to this random function. And then in the assert mock called, where we are validating if we actually called the function, then we're simply looking up in the history things that that match, and then we count them. And if the count is not enough, then we throw an exception. So does that make sense to everyone? Cool. So in the real deal, what we need to do is that we find the function in the function table, we generate the random function, the bootstrap function, that will call another function that will select the correct body of the mock, because you can have multiple mocks with different parameter filters and different bodies and so on. We have to add the aliases. Filter parameters, I already mentioned that. And then we have to filter parameters again when we are counting the calls and so on. So a few steps, not very complicated, but the code will get more complex, as you will see. So this is a streamlined implementation of a mock. First, we resolve the command to get it. I will get to that on the second slide. Then we have a mock table, and we check, is there a mock in the mock table? If no, create one. So if there isn't a mock, what we do is that we inspect the command to get its metadata, and those namespaces are coming from the system management automation, sorry. So if you want to make this code work, which I think would be a good exercise for you, if you took my code and tried to build like a minimal implementation of Pester out of it by looking at Pester code and my code and trying to make it work. I think that would be possible and quite a lot of fun, at least for me. So we have this metadata that describes the function, and from that we can generate the param block, which will give you all the parameters with the parameter sets and so on, all the things that you have. So in case of the built-in commandlets, there is quite a lot of stuff that you can get. Then we generate the new name for the bootstrap function, and that would be the GUID. Then we generate the mock body, we will get to that in a second, and then we create a new script block for the body, which is this one, the mock script, and we create a new function that will be the bootstrap function, the function with the random name. And then we of course have to set the alias with that's pointing to the GUID, and that's it. That constitutes our mock. So in here we are just preparing for the next steps and saving the original command so we can refer back to it. And so if the mock already exists, all of this is skipped, and then we just add the filter and the body. So the filter is the parameter filter that you specify in your parameters, and the body is the mock with script block that you specify. So those are the resolve commands, new function. Not very interesting. I noticed that we are not using commandlets in them. Maybe because it's an old code, maybe because someone just tried to avoid commandlets because you can mock them and then we have to protect them and so on. And in the resolve command, we just find the command. If it's an alias, we get the resolved command. There's actually a while loop, and I'm not 100% sure it's needed, but I don't think it's needed because the resolve command is already usually or always what I've seen is the command that we actually need, so maybe the while loop is not needed at all. And then we create a new function, and we set it to the script scope, so it's global. And then we put in the definition of the function that I will show you right now. So we have this generate mock, and in it we have this prototype. We have this prototype function in the project. I don't know why, but it's just holding the body that we take from the prototype function and then use it somewhere else. And the code looks quite like this. Well, not quite like this, but this is the gist if you take away all this weird spacing, all the escape sequences, and so on. And what we do here is quite simple. We just capture the PS commandlet variable if it's available. We capture the session state, and then we call Invoke Mock function that's exported from the framework. And you can see that we have these hashtags because this is just a template that will be modified later so we can generate the function. And then we have this other function that this is what you've seen in the previous slide, but shortened, so it only has the relevant pieces. And here we just replace the name, replace the from block, which would be begin, process, or end. And then optionally, we provide the input if we are in the process block to get this complete function definition that we then save in the bootstrap function, in the function with the random name. So in the real code, we are doing it a bit more differently. So instead of using underscores, we're using this dollar curly braces escape sequence, so we can put anything in it and it will be still a valid identifier. So you can see this very pretty variable name with spaces and so on. I'm surprised there is no emojis or something. But if you want to do PR, then just do it. Yeah. And then we have this reference to the get command saved that we invoke, and we get out the definition of get variable, and then we invoke that to get the definition of args, or to get definition, sorry, not definition, the value of args, which is the arguments that you passed in, or the value of other properties. This is not the complete code, it's just, if you ever look at the bootstrap function, it doesn't look as nicely as this, but the code is exactly the same. So then we have this invoke mock, quite simple. We just find the body, as I said. You can have one mock and you can attach different mock with scripts to it and different parameter filters to it. So that's what we need to solve in here. We need to resolve to the correct body of the mock. So the first thing first, find the mock, find the body, execute the body. Otherwise, call the real command, which can happen if you don't have a default mock. That's a mock without any parameters, but that's not interesting code, so I just omitted it here. Then the execute body, nothing complicated again. We just use the ampersand operator to run the body script block, and we splat the bound parameters over it. The two-param block is quite interesting, and the body, find the body as well. This actually doesn't do exactly just find the body. It finds the body, it generates the filter, executes it, and then returns the body. So what we do here is that you give us this parameter filter script block that uses some variables, but you are not defining the param block that would, in reality, define those variables inside of it. And we are running in strict mode, and we are running inside of the Pester module scope instead of in your scope. So we need to define the parameters, and we do that by generating this param block here on the top. So this looks at the bound parameters and defines or generates a param block that includes the dollar and name of each of the keys. That's in curly braces for escape sequence. So in the end, you will get param blocks in your filter with script block. So in the script block that you define to the parameter filter. And then for each of those, we have to execute them, set the string mode to off, and if they resolve to true, then we say, okay, this is the body that we want to find, and we return it. So we selected the correct body attached to the mock. You can see that I'm using for each here, but in reality, we are ordering the bodies as they are registered, so the defaults go on the top, and then the ones that have parameter filter go on the bottom. And we go from, you define this, from the oldest to the newest. So if you define this closer to the call, it will be picked up first, and then we go from the bottom up. So that way we can pick up the ones that have the parameters filters first, and then we just pick up the first one that doesn't have a parameter filter, because the default is true. Make sense? Or is it getting too confusing? It won't be anymore, don't worry. Then the assert mock called is simple again. Look in table, then do the same thing. Actually, the thing in here is partly this function and partly something else, but it was easier to put it in one slide and as a whole concept together. So we have call history, and for each item in the call history for this particular mock, we just execute the parameter filter that you gave us, and if it's true with the parameters that we captured during the call, then it's a matching call and we can count it. What this gives you, instead of if you just provided the parameter filter here and then you had to provide the same parameter filter here, is that you can provide a default mock that has no parameter filter on the top, and then you can have multiple assert mock calls with different parameter filters as you see fit. So you don't have to do 5 different mocks. You can just do one, and then you can filter the calls however you want. And I find this quite useful because I don't have to repeat my code that much. And so since this is an assertion, what we have to have? An exception. So we throw an exception if it doesn't match. Okay, so this is how mocking works. Everybody understands? Did I hear no? So from all of this code, I omitted quite a lot of stuff, like how do we handle modules? Not difficult, you just attach the module name somewhere to the table so you can have qualified calls. But one very important thing that I haven't mentioned yet is scoping. And that one you have to understand the internals. All the other stuff is just extra fluff. So in here, a typical test again, we have this function getPlanet, and we have this function filterPlanet that helps us filter the planets that we loaded from JSON. And this function isn't exported from the module, but you want to test it anyway, because, I don't know, it's easier to test than loading a file, filtering it, exporting it to JSON, and then comparing the two files. So you just want to look, oh, is this filterPlanet correct? Then mostly my function is correct. If I don't see the files in the end, then I need to change this one line of code. But other than that, the important logic is helping, the important logic is located in the filterPlanet function, so I want to test that. But it's inside of my module, so I need to reach it somehow. So what you do is that you import the module, you specify the in-module scope, that would be planet, which is this one, and then you can execute the filterPlanet directly, because we did some magic and we switched you to the module scope. So most of you probably know the trick, but there is a different twist to it a bit. So the problem is that we want to run test inside of a module, and that's easy. More importantly, sometimes we want to get your script block, like in the case where we do the filtering, we want to modify it, and then we want to run it in your user context, so it picks up the correct variables and does the expected thing, and that's more difficult. So last year there was a talk by Bruce Payette. If you have the chance, go and see it. It's on PSConf EU, and it describes how session states works and so on. So to sum up this whole talk into 1 minute, you have session states, and session states are these big silos that hold variables, functions, scopes, and other things like test drives and so on. You have one silo per module, so one session state per module, and then you have one that you can also imagine as a module that's for the user code, user execution context. And then everything is a script block. That was one of the messages. And when you create a script block, because for us it's important, we're mostly dealing with script blocks, so that's important. And script blocks, when you create them, they attach to the session state in which you created them. So if you give us your script block, we convert it to text, we create it again, then it's attached to insides of Pester. And that won't work. So let's see how it actually behaves. That's my only real demo. How much time do we have? Okay, that's nice. Can everybody see it? Oh, nobody can see it. Duplicate. Can everybody see it now? Nice. So we have this new module. You can imagine that's Pester, but it can be any other module as well. And we define it in memory. And then we import it. So as you would do with your normal file module, but I just don't want to fiddle with files. Then we have the script block that just prints the value of the location variable that's attached and or that it resolves. So I will define that. And then I can define this location that help us understand where we are, what we are executing. And so if we just call it in the top level user code, we get what we expect. We get the XX, which comes from the script block, and then the location resolved to this variable, right? That's how we expect it to work. So we do the same thing in a script block that creates a new scope, and there we define location one more time. And so as everybody knows, when we have a parent variable and then we define a variable underneath it in the child scope, the child scope variable will be resolved first. So now we expect it to resolve to this one, and it does. So yeah, everything still works as it should and as we want. So now we want to do something similar to what we do in Describe. You give us a name and you give us a script block, and we have this function in this call. In this example, it's called f, but it could be a Describe or it block. And we execute it, and I didn't point this out. Here we have location in module. So if it resolved to the scope of in module, it should say x in module x. If it resolves to user scope, it should say in top level scope, because this scope ended. So apparently it resolves back to the user scope, because as we said, script blocks are attached to the session state that creates them. And so still it works nicely. That's what we want. We want your script block executed inside of Pester and get back to you. Now, if we do a similar thing, and what we can do is that we take the ampersand operator, we give it the module object, and we execute the script block, which will execute it inside of the module. So now it binds to the module. So they must do some magic. They take the session state, they put it in a script block, maybe create a new one, execute it inside, so it resolves to this one. So this is still useful for Pester. And then we can do the thing that would a Describe do if we defined it as just a script block and we execute it inside of the module. So we pass a script block as a parameter to the Describe, and then we execute it. And it still works like we expect, right? So what's the problem? The problem is that sometimes we need to do this. So we execute inside of module, we get a param, and then we need to modify your script block and create it again. And then what I wanted here to happen is that to say execute it in user scope, not in module scope. But it executes in module scope. Okay, so seen the talk, now I'm thinking, okay, I have a session state, I have a module, so PowerShell is really good at converting stuff between and helping you out. So I will just take this, I will take the session state, and I will just execute it like this. So here's the session state object that I got from my execution context. Here's the ampersand, just, be clever enough, just do this, execute the script block, and it should work. And it doesn't, because it just doesn't. So it needs to be done differently. So I just found out there is an API. I don't know in which version it came, but what you can do is that you take a session state, you take the invoke command, and then you invoke the script. You pass in the session state, pass in any script block, and then you pass in array of objects, which would be the parameters to that script block, and then you execute it. So if we do this, then it will behave correctly. So we will take your script block, change it. In this case, we don't do any change. We just attach it to the module scope. And if we invoke it inside, it gives us the expected result. And if we invoke it through this code, it executes outside in your session state in which you passed us. So yeah, that's how we can go around it and implement the features. But that's not how it's done inside of Pester. So instead of that, we are depending on the internals of the code, and we are using reflection. If you want to learn more about reflection, there is a talk, I think 2 slots from now, or maybe it's tomorrow. I think I mentioned it. Oh, it's 14:15 to 15:15 by Jared Atkinson. So go see that if you want. So this slightly complicated code only does this. So we have this session state internal variable, we have session state, the object that we got, and then there's this property on it that's internal, and it's called internal. So normally we cannot reach it. But through reflection, we can do whatever you want. So we just reach inside of the object through the boundary, take out the value, and then we just take a script block. We take session state internal, which is another internal property. We take this object, set it into this object, and we have done what we need. We have attached it to the session state where we need to invoke it. So yeah, little trick, if someone knows if this API was present in PowerShell version 2, then let me know, because I couldn't find it. If you know a cleaner way of doing this, then also let me know, please. And now you know everything about Pester. And we're right on time, right? Maybe we can just execute it so you believe me that it works. Oh, there's some error. What did I do wrong? Set script block scope. Oh, I didn't define this function. One more time. So I don't think I need to go through the summary. Just if you can help us with the development, hope you understood more about how it works internally. If not, it's just executing script blocks, and I'm ending.